Hey y'all, it's me, Miss B, and today we are understanding how to solve exponential and logarithmic functions and find the domain of functions. But first I want to talk about log base 5 of x equals y. And I'm going to start off by graphing remember we change it to base, so I have 5 to the y equals x. So I'm going to do -1, 0, 1 is my points. So x is 1/5. 1 and 5. We work backwards there. So I have an asymptote at x equals 0, which is not quite showing up for me. So there's my asymptote in the green. Maybe. There we go. And then, and then I know that my domain is going to be from 0 to infinity based on just this right here. So I'm going to go ahead and plot these points. We've got -1, 1/5, 1, 0, 5, 1, 1, 0, oops. This should be, dang it, 1/5, -1, there we go, 1, 0, and 5, 1. So then our graph is gonna go down like this, and then up, and keep inclining like that, pretty steeply. So we have to answer the question, is there any instance where x can be equal to 0? The answer is no. There's an asymptote at 0. So because of that, the answers will never be equal to 0. Now this is going to come into play when we are finding the domain of these functions. So looking below here, what I need to do is this right here, this x minus 7. I'm going to set that x minus 7 greater than 0, because that's what ends up happening. It doesn't even go below 0. So then I solve and I get x is greater than 7 for that asymptote, for that domain. So that's really easy, and then we always want to rewrite as 7 to infinity. Now we've already kind of talked about this a little bit, but now we're just putting it into words. All right, so for this next one, actually you go ahead and do this one next to yourself. Should have done x plus 4 greater than 0. X is greater than -4 then, meaning we go from -4 to infinity. All right, now for this next one here, I've got a factor, so I'm going to set x squared minus x minus 2 greater than 0. Now, two numbers that add to be -1 but multiplied to be -2 are -2 and +1. So what I'm going to do is I'm actually going to set x plus 2 or x minus 2 equal to 0 and set x plus 1 equal to 0 and solve. So I get x equals 2 and x equals -1. So then here's -1, here's 2. I'm going to test some values. So I'm going to plug some values into the equation. Let's test -2 in our equation. So I have -2 minus 2 times -2 plus 1, and that should be greater than 0. So I get -4 times -2. So I get 8 is greater than 0. That is true, so I'm going to fill in that section. But it doesn't include that. If I plug in 0, I have 0 minus 2 times 0 plus 1, giving me negative 2 as my answer, which is not greater than 0. So that is not filled in. If I plug in a 3, I get that answer is greater than 0 as well. So when I write this out in the form, I go from negative infinity to negative 1, and then from 2 to infinity. If you remember from the beginning of the year. Okay. So now we are going to move on and do some of these problems together. Okay, so before we solve equations, we want to find the domain restrictions first. So I'm going to go ahead and set x greater than 0, giving me that 0 to infinity is my domain. So then I'm going to write this as log base e of x equals 6. Then I'm going to bay it, or unbay it, I should say. So I get e to the 6 equals x. And there we go. That is included in our answer. That's in our domain, so it counts as an answer. Okay, this next one here. Actually, yeah, let's do this one. So I'm going to save this one for you guys. All right, this one here, number 3. So I'm going to rewrite this. So I'm going to set x greater than 0 again. So 0 to infinity is my domain. So I have 4 to the negative 3 equals x. 4 to the negative 3 is the same thing as 1 over 4 to the 3, which is then equal to 1 over 64. So that is in the domain, so that counts as a solution. All right, number 4. All right, for starters, I really want to move this. So I'm going to go ahead and rewrite this as log base 2 of x squared to the 3rd, which of course an exponent to an exponent, we multiply and get x to the 6th there. So then I'm going to set x to the 6th greater than 0, and again 0 to infinity is my domain. I'm going to bay this. So I have 2 to the 4th equals x to the 6th. Solving, we get 16 equals x to the 6th, and we take the 6th root of both sides. We get x equals the 6th root of 16, which is still within our domain. Okay. Let's do one more here. It's this last one, number 6. So what we're going to do is we are going to make sure that we set both 2x plus 1 greater than 0 and 4x minus 6 greater than 0 and solve. So x is greater than negative 1/2 and x is greater than 3/2. Okay, so then we're going to make our little thing here. So negative 1/2 and 3/2, and we're going to test some values. So let's test negative 1. ln of negative 1, or negative 2 times negative 1 plus 1 equals, oh goodness, ln of 4 times negative 1 minus 6. So I have ln of negative 2 plus 1 is negative 1 equals ln of, would that be negative 4, negative 10. So that does not work. Nope. Let's try 0. So we have ln, why do I feel like I'm not doing that right? Oh, let's do. Alright, so let's type that in. So we have ln of negative 1 times parentheses, where are they? 2 times negative 1 plus 1 is undefined. So because that's undefined, that's why it doesn't work. So that is an undefined answer there. That's why we put a little frowny face. Okay, so this is undefined. So there's no values there. Let's go ahead and try 1. So ln of 2 times 1 plus 1 and ln of 4 times 1 minus 6. So we have ln of 2 times 1 plus 1. That one's good. So we have ln of, what was it? 4 times 1 plus 1, or minus 6. All right, and that is also undefined. Now, the reason why we're getting undefined is because this is ln of negative 2. We can't have any negative ln's, just like we talked about at the very beginning. So that is why that doesn't work. ln of 3 over 2 is going to work. I'll kind of spoil that for you. So then our answers go from 3 over 2 to infinity. Let me kind of rewrite that a little bit neater. So our domain is 3 over 2 to infinity. So then I'm going to set 2x plus 1, because if I take e of both sides, then I can just take 2x plus 1 and set it equal to 4x minus 6. Because those ln's cancel each other out. So I add 6 to both sides. Subtract 2. So x equals 2 over 7. I messed up. What did I do? 7 over 2. Ha! X equals 7 over 2, which is greater than 3 over 2, so that works as a solution. Okay, let's do one more here. All right, looking at this one here. To find the domain, I'm going to set x greater than 0 and x plus 2 greater than 0. So I get x is greater than 0 and x is greater than negative 2. Putting it on my number line. Negative 2 and 0. If I plug a negative 3 in, I get negative 3 plus 2. Right here, negative 3 plus 2 is negative 1, so that's not going to work. Negative 1 plus 2, positive 1, negative 1 here would make that negative 1, which we don't like. 1 gives us positive numbers for both values, so we go from 0 to infinity for that. Domain. All right, so to figure out what this domain is, I'm actually going to move this over here so we have space. So I'm going to rewrite this using my laws or rules. So I'm going to have log base 3 of x times x plus 2 equals 1. Then this whole thing right here, this is my B, this is my A, this is my E. So I have 3 to the 1 equals x times x plus 2. You can go ahead and simplify that to be 3 equals x squared plus 2x. And now I can solve by subtracting 3 from both sides and factoring. So when we factor, we have two numbers that multiply to be -3, but add to be +2. So we have -1 plus 3, set equal to 0, and x equals 1, and x equals -3. However, -3 is not in the solution set because it's not in the domain. Oh, where's my domain? It's not in my domain. So that is why that is not a solution.